Hey, welcome back. All right, we're going to talk about this part three here, controlling two motors. Again, um, we're going to save this. They want you to save it as part three, so I forgot to do that on the last one here. But I would to go up here and type it and save it as part three. I go up here and I hit File, Save As. It should go right back to my last spot, and I would type in here part three. So the first one I did should have been part one, then part two, and this is part three. So you can have lots of different files here. Write a program that performs the following simple behaviors. Use natural language functions where appropriate as shown below. So they're telling us here to use natural language functions. I probably said that earlier and I just skipped and read right over it. It says turn the right motor on forward at half speed for 5 seconds, then stop. Start motor. Right motor. Half speed. Semicolon. Wait 5 seconds. Semicolon. And then stop motor. Right motor. Semicolon. Now, what are they telling us to do after that? Turn the left motor on in reverse at 3/4 speed for 2.5 seconds, then stop. So what this is really, sorry, is this is really similar to our LED, except they're just having us do different motors. I'm going to do my left motor, half speed in reverse. So I'm going to say -63. Actually, I said 3/4 speed. So 3/4 of 127 is going to be about 80, 82, somewhere around there. So I'm just going to type in 82. And then it said a wait time of 2.5 seconds. And make sure you put that semicolon at the end of it. And then stop motor, left motor, semicolon. So it's really just that fast you can get this done. Turn both motors on at full power and spinning in the same direction for 7.25 seconds and then stop. So now here's what I'm going to do. For those of you who are not listening right now, I'm going to type in here half speed. Alright, but you should be typing in 127 because it said full speed. I'm finding a way. Right now I'm going to find out when I grade this who was listening and who was just watching. And I'm even going to put a -63 in here. Again, you shouldn't have it be negative. You should have it being in there +63 or +127. Again, I'm just going to find out who was watching, who was just watching, and who was paying attention. Wait, and it says 7.5 seconds, I think. Doesn't it say 7.5? 7.25. Semicolon, and then after that, I want to stop. I'm going to scroll down to see what it says here. Stop all tests. I just kind of guessed. Oh. And I've messed up. Let's go stop all. There we go again. Yeah, if that's not working, you can simply type in stop motor. I could type in right motor, semicolon, and I can type in stop motor, left motor. But I'm pretty sure if you type in stop all task, it's a little faster and it just stops everything. Again, this semicolon is important up here because we're telling it it's a command. You're saying do this. I'm saying to do this now. All right, you'll take a snippet of it, print it, glue it into that engineering notebook. The next one here, controlling a servo motor. All right, Team A, everybody here is Team A. All right, open the template, click, this will be part 4. So I'm gonna go up here, get rid of all this. Some of you, I guarantee, are gonna copy or delete too much of this. You're gonna get rid of this bracket here at the end. You gotta have that. Tells your computer you're starting a program. This tells your computer you're finishing a program. I'm gonna go up here and change it to part 4. I would go up here to File, Save As. I would save it as part 4. Of course, you know what I never did. I never saved it at the end, but hopefully you guys are saving it at the end. Okay, use the program below in the task main section of the program between the curly braces. So it says set servo motor. And this isn't telling it a speed, this is telling it to go to a position. Alright, so I'm going to say set servo. And I've now got to tell it, well, what servo? The servo motor. I want it to go to -127. And I've got to use a colon. Now notice here, there's a wait. And then it tells me to make the servo motor go to 0. Wait 2 seconds, semicolon, and I'm going to set servo motor, and I'm going to 0 now, semicolon. There's a wait time, I'm sure. Alright, I'm going to wait 2 seconds. Alright, so it's going to go to that spot immediately, and then it's going to wait 2 seconds before it goes to the next spot. Make sure you put your semicolons in there. Set servo. So now it's going to go to the complete other side, and we want it to wait for 2 seconds there. Set servo motor 127, and we want it to wait 2 seconds there. Again, now I should be done. There's at the beginning of my program, there's the end of my program. I would compile it. I forgot to show you that on the last one, but make sure you compile it. Notice I don't have any mistakes. Right now it's telling us that this should work perfectly. Now that's not always the case. It's really like a grammar check. Think of it that way. It looks for really big time mistakes. Alright. Power on the Cortex, compile and download the program. If you have any errors, check that. Raise your hand, I'll come over and help you. Alright. Take a snippet of it, copy it, print it, put it in your engineering notebook. Now, on this one, I'm going to let this one be for you here, but program the server to go to position -127 for 2 seconds. Go to here for 3 seconds. Go to 0 for 2 seconds. Go to position 63 for 3 seconds. So it's exactly what we just got done doing here, except you're just basically changing these numbers and changing your wait times. Well, hey, hopefully that was beneficial for you guys. I'll catch you on the flip side.